right, you need your calculators. Can you solve this, or can you use your calculator to evaluate these functions?
Yeah.
This is on our homework.
What question is, like, what are we doing? 5.1.
5.1.
What's the name of your fancy calculator you have on your iPad?
Desmos?
No, you have like the really
Wolfram Alpha?
Wolfram Alpha?
Wolfram?
You have like the picture of a calculator, and you can press the buttons on it. You know what I'm talking about?
I do not.
You should.
Calculator app?
No, you have like a calculator on your screen.
You have a TI-84.
I have a TI-84 on my desktop, yeah, not on my not on my iPad. I didn't know what you wanted.
You're supposed to read my mind.
I get that.
Yeah.
Holy smokes.
See, I don't get the one. I didn't choose the one that was x equals pi because it doesn't.
That sounds so hard to
It's
me.
scary.
It's like, it was like point
6 decimals.
0.0006.
Brother.
What's the problem?
The pi one was like,
It's scary.
it was 2 to pi, and it was like, wasn't it like 0.006?
Well, I haven't asked you to evaluate 2 to the pi.
What does that one say? X equals 2 to the negative pi. It's just as scary though. What is the fraction up there? 2 over
3 halves? This one?
3 over 2.
3 halves? Yeah, and this is not by hand. I want you to do this on your calculator.
Wait, Mr. Eagle Shadow,
Hmm.
do you have AAA batteries?
I do not have batteries. I have a calculator you can borrow.
No, it's okay. My
I
brain
borrowed
just
yours
is
for a
low.
second. Mine died this morning, and when I went to charge
Is it on the charger?
No, I left it in the charger. It didn't. It's charging me.
Oh, okay.
There, look.
Did you borrow the FAS math calculator from me?
No, I've never, on my life.
Somebody did.
Okay.
I did for state testing, or
See?
not state testing.
You have an FES math calculator?
No, I'll give it back to you.
You lost it.
I had to get a new calculator because I didn't know where my.
Somebody borrowed it, and I do not have it.
I can come to Mr. Ellis.
Okay, but you often lose things. There's a chance you lost.
You know, that's not unfair.
That's
You
not
say I don't.
unfair.
It's not unfair to say.
That's so
But somebody borrowed the FES math calculator.
I think you're like one of your
No.
things.
I have the first one.
Rejected the premise. What did
I
you
have
get?
all of them. Okay. So this is the f of x equals 2x. You do f of x equals 2 to the negative 3.1.
And you get?
You get 0.1166 and then 3 or 29. Sorry, because I know you wanted it for 6. Never mind. That's good.
Good. Kira.
I have the second one.
Okay, go ahead.
F of, or g of x is 0.113315.
Okay, because you took it out to 7 decimal places and decided it needed to be rounded.
Yeah.
That's correct. Carla, what'd you get for the third one?
Can I use your calculator? So English.
You're all there, Carl. I thought English was
0.46475.
Yeah, Carla just asked for his.
8.
Okay, so are we clear on how to evaluate the 6 decimal places? What's the procedure?
You just plug it in.
What's the procedure to getting the answer to 6 decimal places?
You go to the 7th and see if you need to round.
Go to 7 and check for rounding. Right.
I actually like this unit more than like the horizontal shift, vertical shift, vertical shrink.
We've been in the unit for 3 minutes.
Yeah, but the homework is pretty easy.
Yeah, one of those.
What should we do?
That's my advice.
That's one.
Okay, I'm gonna switch over to my calculator on here, so we can do one together. And Warren, can you walk me through evaluating j of x?
I don't have the question.
8x when the x is 2, 7.
Alright, so you're... Wait, let me write that down.
It's great. Gotta have a great day.
Alright, we're good.
Let's go.
You press A. Just press that up arrow thingy.
The caret.
Yeah.
I'm gonna press the caret.
Then you're gonna press 2. Then alpha.
Hmm? I'm just gonna say divided by.
Oh yeah, that works too.
Yeah.
Then you're gonna press
And then what?
7.
Mm-hmm.
Yes, you got it. You're done.
And then we're done.
Yeah.
Okay. So I'm gonna take a little side trip here and talk about precision. So we're gonna be doing slightly longer problems now. So can you give me the value of 2/7? Can you give me the precise? Okay, let me ask you this one. Say I had 5 halves as the exponent. Warren, can you give me the precise value of 5/2 in decimal?
2.5.
Okay, and all right, who's up for a trick question?
Me.
All right, Annabelle, can you give me the precise value of 2/7 in decimal?
I looked it up on my calculator.
Okay.
Isn't that 2 sevens?
Yeah.
Because that's the most precise, because you're just gonna keep like going otherwise.
Yeah.
Annabelle, I want to hear your answer.
But that's exactly what I was gonna
What's the
say.
answer?
Because if you did it, it's 2/7, but because if you put it into divided by 7, it's 0.28571428572. You just do 2/7 because it's just the most precise it's ever gonna get.
All right. So if I tried to say if I tried to evaluate 8 to the 0.2857, even if I have 4 decimal places of accuracy, do I get the same answer?
No.
Look, we didn't even make it to 4 decimal places before we started going askew. So when you're using intermediate values, meaning you're not done and ready to report your result, when you report your result, you're probably going to end up with decimal. Like how many children does the average American household have? It's going to be a decimal number. It's going to be 2.4 kids or whatever it is. But in the intermediate steps, you're going to start. Your answers are going to start going astray. You're going to lose precision if you start going out to a certain number of decimal places and then chopping it off is truncating the answer. So, is this a precise answer? These 12 digits or whatever this is? Is this precisely 2/7?
No.
What is it? Why does the calculator give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places of accuracy?
It just keeps going, like it's not.
It does keep going. Why am I only seeing 11 here?
Because at a certain point you have to be like, it's just gonna keep going on, so you have to cut it off. Right?
It's not calculated yet?
Yeah, but there's a couple of reasons here. You're getting really small errors the farther you go. So 11 decimal places is probably good for most purposes. And there's only so much display space, and there's only so much memory. And for convenience, maybe you only need the first 5 or even 10. It gives you more than that. You get 10 and round on this one. But is it precisely the same? No. So If the answer should be 5/2 on a test, and you say 2.5, am I going to count off for that?
But that one is accurate.
If it's supposed to be 5/2 and you answer 2.5 on a test, am I going to count off of that?
No.
No. For the reason you just said.
No. Okay.
No, it's not. It's a precise answer. It's a precise answer, and although I prefer to have things all in an exact answer, I'm never going to quibble about 2.5 as a representation of 5/2. I really can't. It's an exact answer. But if the answer is pi over 2, and you estimate, and I haven't asked you to estimate, then that's not as precise as you could be. And the reason why I even care, why I'm even talking about that, is because in the longer problem, when you have 5 more steps to go after this, and you're already truncating your answer's going to go straight. Okay, that's enough of my diatribe. So can you graph? So this is a paper and pencil exercise. This is not a calculator exercise. Oh, I thought I was showing you my iPad. Let's try that again. There we go. So let's graph F and G without using a calculator on the same coordinate plane. So to graph by hand, what's a sort of reliable fallback tool that we can always use? Sydney, what technique can I use to graph a couple of weird functions that I'm not 100% sure what they look like? Without using a graphing tool, without using Desmos or my graphic calculator. What do you want to do?
Pick on the
Graph.
Solve them, write it out.
Solve them, write it out. What?
Look at some point. Look at 0, 0 or something.
Okay.
See if it works.
What if I look at a bunch of points?
Yeah.
So let's get a range of points.
I think this is gonna be good. Here I go.
Does that say 2x or 2 to the negative x?
Where?
Or
2 to the x.
No. Oh, okay. Never mind. Sorry.
All right. So I'm going to let you volunteer who wants to fill out a column, and you can pick based on whichever one you think is easiest. Annabelle, which one do you want?
I can do g of x, or I can do f of x. Sorry.
No, I want to do a column at a time.
Oh, okay. So then, I can just do negative 3 right now.
Okay. Well, jumping right into -3. Okay, let's go.
So you do negative 3 or 2 to the negative 3. Negatives you like 0.125.
Mm-mm. We're going to stay in fractions.
Okay, so then you do.
How can I rewrite this? Get rid of the minus sign and the exponent?
You would have to turn it into negative 2, correct?
No. What's the multiplicative
One
inverse?
to the negative third. 1 to the negative third. You could
2
do.
over 1 to the third or something?
1 to the.
No, you do 2 to the negative third times 1 to the negative third. That way they cancel out, correct?
What is the multiplicative inverse of 2?
1/2.
One half. And what's the implied exponent here?
1.
And this can be written as, this can be written as,
-1.
yeah, -1. There you go. So what's another way to write 2 to the minus 3?
2 to the 1/3.
No. 1/3 is a cube root.
So that gives you 2 to the -1.
No, see what I did here is I
1/2 to the negative.
1/2 is the same as 2 to the minus 1.
2 to the 1/3.
Oh, no.
No.
Oh, I see. 3. Yes. 3
Yeah.
half. Because you just did it. You just switched it.
So
then if you
I-
do that, then it's 3/2.
No, let's look at this one again. What's the implied exponent here?
1.
1, it's positive 1. So if I take this out of the numerator and I make the exponent negative. Right.
1/2
1 over 2 to the third. So this exponent here in the denominator compared to an exponent of the thing that's just in the numerator, you just flip the sign. Flip the sign. And it's because of this reason. It's because the multiplicative inverse of 2 is 1/2, which can be written as 2 to the minus 1.
So then
You know how we always call like inverse functions? We call it f inverse of
Yeah.
x. It's the same idea here. This is not literally an exponent. This is just the idea of the inverse.
So then 2 times 2 times 2, so 4 times 2 is 8, so 1/8.
Yeah, great. Good job.
Can I do the g of x equals 4?
Yeah, you're doing the whole column.
Oh, yeah, okay. So then
So
you get,
g of minus 3, I should have written this as f of minus 3.
okay, so then you get equals 4 to the -3rd. And using the same thing that we did before, we're going to put 1 on the top, so 1 over 4/3. So then 4, we just did this.
4/3?
Yes.
4/3?
Not 4/3. You know what I'm saying? 4 to the third.
4 to the third, right. But you're telling me what to write. So if I write 1 over 4 to the third, 4 thirds, then I'm in trouble.
Not that.
Yeah,
Four to the third.
I'm
Four
in
cubed,
trouble there.
4 cubed.
4
And
cubed,
it's 4 times
which
4
is 4 times 4 times 4.
So then you get 16 times 4, which I think is 6. Wait, let me look it up. 4 times 6. Yeah, 64. Oh my gosh, I'm so proud of myself.
Nice.
So.
Oh, you're killing it.
4. Yay.
So 1/64th.
Yeah.
Right. Okay. Next volunteer. Karen, you do -2?
Yeah.
You want to do it long ways, or can you just tell me? How do I write it? How do I write, what's my function for f of -2?
2 to the -2.
Which can be written as
1 over 2 to the 2, like
2 squared.
squared. 1/4.
Yeah, and you're done.
And then 4 to the -2 is 1 over 4 squared. Is 1/16.
I think we're getting easier as we go.
I could do.
All right, Carl, let's go.
this one. 1/2. 1/4.
Nice. All right. Trick question. Who's ready for the trick
I know,
question?
I know.
Oh, no, Charlotte, raise your hand. No, Charlotte, raise your hand.
Oh my god.
Let's go.
Is it just 1 for both? Or is the 0?
You're asking me. If you're asking me, let's do it out longhand.
No.
F of 0 is,
No, she wasn't asking. She
How
was
do I-
telling you.
how do I write f of 0?
2 to the 0.
2 to the 0 is what?
I don't know how that works.
1.
And
Why
g
is
is
it
0.
one?
Why is it 1?
Yeah.
Oh, why is it 1? Oh, I was hoping you were going to ask that question.
Thanks.
I'm ready for you. Let's do y equals 2 to the x. Let's do y equals 2 to the, no, you got to the x. And let's also do y equals 4 to the x. Not squared. Not 2 to the square. There we go.
They all go through.
Let's do y equals, what do you want to see?
8 to the x.
I want to see 32x.
Why 6?
I didn't want to emphasize that it has to be powers of 2. Even the number's good enough.
Yeah.
So you see 8 to the x goes really steep past 1, but it's the lowest one, less than 1. You see how the red line 2 to the x is the lowest one once you go to the right of 0. But look what they all pass through.
Why did they do that?
Uh,
Why does that happen?
So it's exponential growth. We're gonna graph some things by hand. We'll see why, but we're finding out just in the just by making a table here. This is why. This is really why. This is what that graph is showing us. But let's go ahead and finish out the rest of the graph, and we'll do it by hand, and we'll see that it really works. But that is a graphical understanding of why any non-zero base to the 0 is 1. All right,
I
so
want a logical understanding.
so like the number. Okay, all right. Let's finish out the graph, and then we'll talk about the reasons why, and then we'll try to get an understanding of that. All right. So Charlotte, what do you have for 0?
1 and 1.
1 and 1. All right. Who can do 1?
I'll do it.
All right, Warren. Let's go.
2, 4,
Nice.
And Eric, do the last column for us.
The first one is 4,
Yeah.
and the next one is 16.
Yeah.
Yeah. All right. So let's graph it. I'm gonna clean this up a little bit. Don't need all this stuff. And how am I supposed to graph this?
You bought it.
You put it on a coordinate plane.
What does that mean?
Same kind of different colors.
Oh, let's do colors. Let's go. All right, so I need to go as left as 1, 2, 3, and as far right as 2. 1, 2. So, Amelia, can you give me a point that you want to graph based on
I know
the
what
table
I
that
would
we've made?
graph.
4.
So x is 4.
Yeah.
It's not on the chart.
No, that don't make no sense.
1.
You want to do 1?
Yeah.
So let's do 1. So what point is that? Point or points? 1.
Okay.
So it's a coordinate pair has an x and a y. So what's my point?
2 and 4.
So 2 and 4?
I don't know.
So somebody else do that and we'll come back.
It's,
No. Let's keep going. No, Warren, you can't do all of them.
I could do this.
No, Carlo, you can't do all of them, man.
No, but I don't.
You gotta share love.
It's 1 and 2.
Charlotte, give me a point.
Oh, no. Okay, -2, 1/4.
So we're gonna graph this point right here. So it's minus 1, 2, and then that would be a half. So that's a 4th. Okay. Maybe I want to be doing this in blue. So this is my blue function. And this will be my red function. So I'm gonna plot -2, 1/4. Sam, can you do one for me?
Which one?
You pick. Other than, I guess maybe I could say you've already done that one.
Can I do 1 and 1?
1 and 1 does not appear on the chart.
Or 0?
0 and what?
1.
0 and 1 does appear on the chart.
Oh.
And what, can you give me one?
Yeah. Can I do 1 and 2? Or, well 1,
1 comma 2?
1 comma 2.
That's here.
What a
Yeah.
point. What a good point.
1 and 2. Yes, that's right. And Sydney?
Maybe do 2 and 4.
2 and 4. So 1, 2 over here. 1, 2, 3, 4. Right? And then Amelia, can you give me one?
1/8.
1/8?
Yeah.
It's not a coordinate pair. I need an x and a y. 1 and 4. I'm graphing the blue line. The blue line right now. Negative 1, 1/2. That's 1. So negative 1 and then 1/2. Good job. And then Kira, last one.
Negative 1, 1/4.
Lock in.
Oh, negative 3. Wait. Sorry. I don't
All
remember
good.
just
All good. All
the
good.
blue.
And what is it? What is approaching?
I think it's
Oh.
approaching
Zero.
infinity.
As x approaches,
Oh, 0.
as x approaches 0. No, we do not have a.
As x approaches infinity, y approaches infinity.
That's true. As x approaches infinity, y approaches infinity. But what about when x approaches negative infinity?
It probably approaches 1 or 0.
Y approaches 0. F of x approaches 0 as x approaches
It's like an
negative
asymptote.
infinity. Ooh, what kind of asymptote?
Like or
Or is asymptote. Yeah. So this kind of goes this way and it crosses through 0, 1, and then takes off that way. And then where do we stop? Warren? Can you start us off?
Actually, that would be me.
Oh, Carlos. Sorry.
Who's gonna actually?
Actually, I beg your pardon. Let's start on the red graph, Carlo.
Yeah, I want to do point 2, comma 16.
2, 16.
Yeah.
So it's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Up there, man.
Yeah. Okay.
I
Or-
want to do point -3, 1 over 64.
-3, 1/64.
You are.
1, 2, 3 is 1/64th. So is it above or below the blue line?
Below,
It's
on
below.
the left side.
It is below.
On the right.
Eric, you're up.
1 and 4.
Let's do 1 and 4. So here's 1, 1, 2, 3, 4.
No, you.
No.
Now, Amelia,
Negative 3, comma 1/64.
what are you going to do, Amelia?
Negative 2 and 1/16.
Negative 2, 1/16. So here's 1 and 2. Negative 1/16. Yep, good job. And Charlotte and Sam.
0 and 1.
0 and 1. Oh, you stole the 0 and 1. 1. Okay, Sam.
-1 and 1/4.
Negative 1 and 1/4. So do we see the behavior that we kind of saw in Desmos where the one with a larger base ends up with like tinier fractions, less than 1. So it's below this other graph here, less than 0 actually, and then it takes off and goes much steeper to the right of 0. So, getting back to your question, Carlo, what's the basic idea of an exponent?
You're asking me that question.
Basic idea of what's the basic understanding of from, let's say, 5th grade math of 3 squared?
You multiply 3 times itself.
3 times itself. What about 5 to the 3rd? Whoops.
4 to the 3rd, you multiply
5 to the 3rd.
3 times.
Okay, so 5 times 5 times 5. And then what do you notice when we have 1?
That's the same number.
So what is 157 to the 1?
157.
So it's kind of like this is multiplied by itself 2 times. This one appears 3 times in a multiplication kind of sense. This appears 1 time in a multiplication sense. So for positive integer exponents, we kind of have a basic understanding. It kind of came from multiplying by itself. But I would say that we also have kind of a intuitive feel for the negative exponents too, right? So what was 2 to the -3?
That's 1/8.
And it comes from, what's another way of writing?
From 2 to the 3rd over 1. The inverse.
1 over 2 to the 3rd,
Yeah.
and that's the same as, and then we get we get back to our multiplied by itself intuitive understanding here. And that's 1 over 8. So we can see why the as we go further left on the x-axis, we get larger negative numbers here. We end up with smaller and smaller fractions. So that kind of makes sense too. Tipping point is the 0. What is 3,126 to the 0?
It's 1.
What is negative 4 billion?
It's 1.
It's 1. It's always 1. And it looks weird and uncomfortable and confusing, perhaps, to say you have some bizarre pi times e times 4/3 times negative 7, all of that to the 0. But as long as this thing is not 0, it doesn't really make sense to say 0. As long as it's not 0, what's the answer here? Always 1. It's always 1. All of these charts, all of these graphs pass through this point, and you can kind of see that it makes symmetrical sense. So, although we don't have an intuitive understanding of like 3 appearing 4 times, 3 appearing 3 times in a multiplication sense, 3 appearing 2 times, 3 appearing just once, 3 appearing 0 times. Does 0, is it? What is 3 appearing 0 times? 3 appearing not at all in a multiplication sense.
It's 0, correct?
I feel like it could be anything.
Yeah, so the notation kind of, the intuitive understanding sort of breaks down. Knowing the answer, in hindsight, we can say, well, 3 to the 0 is 1. But 3, in a multiplication sense, 3 appearing 0 times leaves you with just 1. That's super not satisfying answer. But you can see from the chart, that from the graphs, that it definitely does make sense. So no matter what I put on here, so here's what I was trying to do before. So what if I do y equals a to the x?
It just goes through 1.
It goes through 1 no matter what.
Wow, that's cool.
Yep, no matter what, it goes through 1.
It's like a sprinkler.
Need some music.
Yeah, very good.
All right, so you try this one.